The question says that explain what would happen if in the capacitor given in exercise 2.8, that is the previous exercise, a 3 mm thick mica sheet of dielectric constant 6 were inserted between the plates while the voltage supply remained connected, and the second case is after the supply was disconnected. So here two cases has been given, and the event that is occurring is the capacitor previously calculated of capacitance 18 picofarad and the charge accumulated on that capacitor was 1.8 nanocoulomb. Now this capacitor is being subjected to two conditions. The first is while the potential difference is maintained or external supply is there to maintain the potential difference across this capacitor, a dielectric material of constant 6 is being inserted. Now we have to find out what will happen. And the second case is the dielectric material is being inserted while the voltage source or the potential difference is not being maintained. That is the case 2. So in the first case, the capacitance will change, and the capacitance with dielectric constant is given as C equals to K times C naught, where K is the dielectric constant and C naught is the capacitance in vacuum. So previously calculated value was the capacitance in vacuum, that is of 18 picofarad. So new capacitance would be equal to 6 times 18 picofarad, that is 108 picofarad. Now since voltage maintained of 100 volt, so it will not change. The capacitance has changed to 108 picofarad. So the charge accumulated will also change because C has changed and V has remained constant, and charge is given by C times V. So the new charge contained would be equal to 10.8 nanocoulomb. So we see here that while the potential difference was maintained, the capacitance has increased and also charge storage has increased because there is a source available for charge. Now the second case was the dielectric material was being inserted while the potential difference was not being maintained. So in this case, we can see that Q before the dielectric material was being inserted, and after the dielectric material has been inserted, the charge on the capacitor will remain same. So the potential difference is given by Q by C, and this capacitance has increased because we know that C is given by K times C naught. So the voltage would be equal to, voltage across the capacitor would be equal to 16.67 volt. So in this case, we see that capacitance has increased just like before, but voltage has decreased because charge has remained constant. And in the previous case, this was not the case. In the previous case, there was a charge sink and source available. That's why the charge rearrangement took place. While in this case, there was no any sink or source of the charge. That's why the potential difference dropped while Q remains same. Thank you.